And the last question that says initially there were 8 moles of SO3 and NO in the system. At T8 minutes, there were 2 moles of SO2 present. Calculate the equilibrium constant. Now we see they have given us moles, so from here we can take this question a little further and we can relate it to what we did in the last lesson, where we have to draw the table. So just to demarcate our page properly again, what we will do is just we will just draw a line across so that we can demarcate that this is the next question, 3.8. Okay, now to just because we don't actually we can look at the question, the equation that we have here. This is the main equation. Maybe I might just copy this and put it down again so that we know what we are working with. Okay, just 1 second. Perhaps I should just rewrite the question. It's not a serious thing. So if you look at it, we have SO3 plus NO, reversible reaction, to form SO2 plus NO2. And we see that this reaction is balanced. Now, initially there were 8 moles of SO3 present. So what we have to do is draw a table. Let's just see how many, 4 blocks down and 4 blocks across. Did you get the table? I think the table is drawn at the top. Oops. You can see how we can bring our table down. Table can come down and we can just take this correctly down. Okay, our table is in the wrong place. As you see, maybe we can just do that sum on the top. Okay, we had a bit of problem setting up the table, so I took a little time out to draw the table. Coming back now, we see that our table is ready. And if we have to draw a table, we know that what we have to write in the first column is our initial moles, how much was used, and how much was formed, and how many moles we have at equilibrium. Now, just to highlight a small point here, we see that we have to realize that in our first part of the table, we have SO2, SO3, and oh, let me just bring this table a little bit down. Oops. And put it a little bit like that, so it will make a little bit more sense to us when we draw our things. We see that this is SO3, this will be NO, this will be SO2, put it a little bit like that. Maybe I should just write it again to make it a little bit more clearer. You can see that here we have our SO3, here we have our NO, SO2, and NO2. Let's just complete the table. An important thing to note here is we realize that SO3 and NO are our reactants. And SO2 and NO are our products. So we can just draw this line here just to make a little bit more sense when we want to work out our equilibrium later on. So to begin with, our question was clear and it said that initially there were 8 moles. There were 8 moles of SO3 and NO in the system. So there were 8 moles. So initially there was 8 moles of SO3 and 8 moles of NO in the system. So these were reactants. This is what we put into the container, which implies that there was no SO2 and no NO2 in our reaction vessel unless it was stated in the question. At 8 minutes, there were 2 moles of SO3 present. So at equilibrium, we can say there were 2 moles of SO3 present. Now this is all that is given, and they are asking us to calculate our Kc from here. Now this is quite interesting, and this will test whether you knew the section related to the table method we did in the past. So what do we do next? And if we look here, we see that because 2 moles of SO2 are put in equilibrium, we have to work with this. And if you look carefully, we see that initially there were no SO2 in the reaction vessel. At the end, there was 2 moles, and this red line I told you will tell us that this side is how much reacted, and this side will tell us how much is formed. So if there was no SO2 at the beginning, and there was 2 moles of SO2 at the end, we can say that 2 moles of SO2 were formed in this reaction. And from there now we can complete the second line. And to complete the second line, we have to use our ratios. And in this case, we are fortunate because we know that 1 NO2 reacted with 1 SO2, reacted with 1 NO and 1 SO3. So that makes our life very easy because now we know that 2 moles of NO2 would also be formed. And that means that 2 NO reacted and 2 SO3 reacted to form the 2 SO2 and 2 NO2. So this is very important, and we must always know that the used and form line in the table always has to do with ratios that we can gain from our equation. Now going further, we can complete the table. If we had 8 SO3 initially and 2 were used, that implies that 6 moles of SO3 is left. And if 8 moles of NO were present and 2 reacted, we can say that 6 was left. And here we can say that if there was nothing and 2 were formed, 2 is left. And we can use this now to complete our Kc value. Now, Kc value, as you know, if we just write down our Kc equilibrium expression, concentration of products, which is NO2 to the power N of 2, NO2 which is 1, and SO2 to the power of SO2 which is also 1, divided by the concentration of reactants SO3 to the power SO3 which is 1, and NO to the power of NO which is also 1. Now to work out our concentration, I did not do it here. So what we have to do is to work out concentration, we have to take our number of moles that are given, and from the number of moles we can work out our Kc value. So let me just put this a little lower because we have to work out our concentration. But how do we work out our concentration? Our concentration is given as number of moles of a volume. Concentration is equal to number of moles of a volume. So what is the volume of this reaction vessel? Let's just look back at our question. There were SO2 present. It does not tell us here. Maybe it will tell us at the beginning. Yes, it tells us here. We see that there's a 4DMQ reaction vessel. So from here we can work out our concentration. Number of moles is 6 over 4, which will give us 1,5. And then similarly here, this will also be 6 over 4, which is 1,5. And here it will be 2 over 4, which is 0,5. And here similarly will also be 0,5. This can also be put to the table, so actually it makes it a little bit easier. So that I must out these columns. You can just put it in now, so that we know that in the future we can put these columns in here to make it part of the table, so that you can work out our concentration. And now we can work out our Kc value for this particular sum. We can say concentration of NO2, it's 0,5, and this will also be 0,5, and the concentration of SO3 is 1,5, and this will also be 1,5. And if you take our calculator and we work it out, I'm fortunate that we got calculator available. I just work this out. We see we can say, sorry, it's 0,5 multiplied by 0,5, which gives us 0,25 divided by, and if you put it 1,5 multiplied by 1,5, and we close the bracket. Oops, I think there's a mistake here. And we can work out the answer. Just looking at the calculator again, we can say 0,5 multiplied by 0,5 divided by 1,5 multiplied by 1,5, and that should give us the answer 1.5, close brackets, and we see that we get an answer of 2,25, and that will be the final answer, which I will just check with you now. Let's just write this down, 2,25, and that will be the Kc value. Let me just double check that answer to make sure that it is correct. There was actually an error in the calculation, so when I double checked it, so let's just do it a little bit slower. Sometimes it is important rather write an extra step and be safe than make a mistake. And if you look carefully here, let me say 0,5 times 0,5 will give you 0,25. We can just put this in now. 0,5 multiplied by 0,5 equals 0,25. And then if you work out the bottom, it's 1,5 multiplied by 1,5, which gives you 2,25. And if you work it out, 0.25 divided by, let's just put that nicely, 0,25 divided by 2,25 will equal to 0,11, and that is the correct answer. And that is the section that we did. If you go back, we see that this is an excellent question where it relates Kc to a graph, and it tests endothermic and exothermic reactions, the interpretation of the graph, a little bit about the Chatelier's principle, the implication of a catalyst, and the table method. And this is an excellent question to revise for the exam. Shukran. Assalamu alaikum wa rahmatullahi wa barakatuh.